Here in this video, we are solving a question that was given in NEET 2023 in ray optics. The question is like this. Light travels a distance x in time t1 in air and a 10x in a time t2 in another denser medium. What is the critical angle for this is? So first of all, we shall try to remember back what do you mean by critical angle. Let us consider this is a boundary that is separating the two media. Let this is a rarer medium, this is a denser medium. When a light ray is trying to move from denser medium to rarer medium, say this is the angle of incidence. If there is no change of the media, the light ray could have continued going like this. But as the light ray is changing the media, it deviates from its original path. As it is moving from denser medium to rarer medium, it moves away from the normal. This is the normal, so it moves away from the normal in such a way that angle of refraction is greater than angle of incidence. Then what happens is, for a particular angle of incidence, that means for a different angle of incidence, where that angle of incidence is called critical angle, the light ray grazes the boundary separating the two media such that angle of refraction is 90 degree. That particular angle of incidence is called critical angle. So we know that at critical angle, mu denser to rarer is 1 by sin c. This also actually comes from the what we have to say, that law called Snell's law. Mu 2 by mu 1 equal to sin I by sin r. This is Snell's law. Mu equal to sin I by sin r. That mu means actually mu always comes in pair with the second bit. Mu 2 is here in this sense, here is mu 2. Here is mu 1. So mu 2 is refractive index of the medium to where the light is going. Mu 1 is the refractive index of the medium from where the light is coming. I is the angle of incidence of the first medium from where the light is coming. R is the angle of refraction of the second medium to where the light is going. Now, when light ray is moving from denser to rarer, to where it is going is rarer, by from where it is coming is denser. Sin angle of incidence in denser medium, particular angle of incidence is called critical angle, by sin r, as I told you, as for the definition, is 90 degree. So mu rarer to mu denser is sin c by sin 90 is 1. But mu rarer is always less than mu denser. So mu rarer by mu denser will be a value that is less than 1, which is not a standard reference for refractive index. So we write it in reverse. Mu denser by mu rarer equal to 1 by sin c. That's the kind of the concept I have written there, the beginning, right? Now, mu is reciprocal to velocity of the light, because if the medium is denser, refractive index is more, so velocity of the light is less. So mu denser by mu rarer, instead of that I can write v rarer by v denser as 1 by sin c. So sin c can be written like v denser by v rarer. Velocity, as per the basic definition, can be written like displacement by time. So velocity in the denser medium is displacement in the denser medium. It is given that 10x is the displacement in another denser medium. So 10x in a time of t2 by velocity in the rarer medium is x by t1. So what happens when I reverse this? 10x by t2 and t1 by x. X and x will cancel. So sin c equal to 10 t1 by t2 So critical angle C equal to sin inverse of 10 T1 by T2. That's the answer for the problem. C, sin inverse of first option 10 T1 by T2. This is how we solve this problem. Thank you for watching.